All right. So let me begin with sharing the screen with you guys. Suppose you can see me. It's my screen. And this is myself. Okay. All right. So yeah, as Giuseppe mentioned, in my part, I will primarily focus on awk. To begin with, I like to just tell, I think you guys are already familiar with the Linux environment. You probably already realize as you move in the world of Linux, you start encountering a lot of animals, especially birds. Linux is like a penguin. New is like a wildebeest. Auk is nothing different. It's another kind of bird. So auk is basically this. It's a bird it's kind of a penguin-like bird, and they can fly. Once Giuseppe visited Cambridge, we had a talk about the penguins, and he didn't believe me that a penguin can fly. See, Giuseppe, you can see the penguins do fly, and it's actually auk. Okay, so yeah, awk is a language actually. It's interesting in the Linux world. There are a lot of analogies, connections between languages and scripts and animals. So awk is a very fast processing language that's created in the Barrel Laboratory in 1970s. It's basically streamline the texted file and do a lot of really fast table type of operations, including a lot of mathematical algorithms and a lot of analysis. So I'm going to focus on the basic part for the awk because it's come down really handy if you want to process some text file in the terminal. The basic syntax looks like this. So awk is basically the command for this environment. An input file is normally a text file, and you can direct this one to an output, or if you don't have this redirection symbol here, it just print out the whatever output you got onto the terminal. And there's a main part is in this curly bracket, which is saying action. So we'll talk more about this action part, how to organize it, how to process it. And the patterns can be also useful. Sometimes, especially, you can have this begin and kind of environment, but we're getting that gradually. So the way I look at this awk, the way to think about this is like a scanner. You scan a document row by row. So let's say your document is coming like a table. It doesn't matter, it's a CSV file or it's a type separated files or just a simple separated by space. Normally it comes in like a table format. Awk will just take in this input file and scan it row by row. And during this process, it will operate on based on the command you provided. So let's get in to this here. Let's just see a first example. In the table format of input, normally, the table can be broken down into columns and rows. So I use a file here, which is Giuseppe also talked in his section. This is available in the folder in the Git repo. So, remember the head command? I just print a few lines in the beginning to show how this file looks like. You see this table. So when the awk come in, it starts scanning like this, row by row, and process options. Normally, options was done by column. In this case, we use this $sign to retrieve the column. Here, which are the column 2 and column 5. Remember this curly bracket? That's symbolize the action part for this awk, and it's quite important in syntax. If you don't have a curly bracket, you got an arrow. And the awk, normally the action part was enclosed by the single quote, and that's just the syntax. So here in this particular line, what I'm doing is basically, I asked awk to read in the file, which is fin, and printing the file of the second and the fifth column. So as shown here. And there are other keywords inside the awk that I can use to retrieve certain useful information. For example, NF is a number of fields. I'm showing here, there are 5 fields in this particular file. NR is number of rows. So pay attention here, the number of fields is not changing because it's a table. So I print 10 lines, it looks like such. It doesn't matter how many lines I print here. But the number of rows is rolling because, as I mentioned before, awk will scan this file like this. It's doing this row by row. So the first row NR equal to 1, second row NR equal to 2. So it's keep going. If I provide this one, you see here I said the tail, which is printing the last 10 files. You see the number of rows is increasing by 1 step for each output. And you can see this can be used to print, as a mechanism to print the total number of lines in the file. So yeah, just a simple operation, columns, rows. That's very widely used in awk, and they represent the number of columns. And pay attention, this $sign is kind of different from the one the bash environment you talk about. So let's see the $sign here, which is $2, is enclosed in the single quote. So it's a kind of in a separate environment. So if I had something outside in a bash environment, it won't carry over into here. So this is a enclosed awk environment. This $2 is reserved to represent the second column. Of course, if you want column 3, you change $3. So this is very basic syntax for row and columns. Previously I mentioned the begin and end actions. So begin and end actions are the actions that's being processed before the input of data and after the scanning process of data. So in this previous example here, we only have the action part. That means the scanner of awk is doing this from the first row until the end. And during the process, it prints out all the information and asks it to. By the time it finishes the last row, the action terminates. But if you have a begin and end, you can do something extra beyond the scanning process. So begin is a command. It starts with this keyword begin and immediately followed by a curly bracket. And this curly bracket is associated with the begin. That means this action together is a begin action. And this begin action tells you just print a string sum. It's just string. So nothing special about this. Then in the action part, the awk starts scanning. So the sum, which is a variable here. So this is sum of 2 different things. This is a string, this is a variable. And the variable start adding onto this file for the value in column 5. In other words, this is a summer container. It's a sum container. It's adding the value of the 5th column as the awk scanner is going from the beginning to the end of the file. Now, by this point, the scanning is finished. Then by the scanning is finished, I use the end action, which will print the final output of the sum, which basically the summation of all the values in the 5th column. You can notice here, if you do C programming or Python, you probably recognize the printf is a formatted output, and %f means it's a float number here. And similarly, you just here just provided the input file. Yeah, so that's basically about the columns, rows, and also the begin and end actions. Like bash, we can also use the pipe to connect multiple commands. Here, the awk does is printing the 5th column, as I did before. Then I pipe this 5th column into a sort command Does anybody still remember what the sort is doing? We just talk about the sort in the bash environment.
Yeah, sort based on the first column, only first column.
Yes, thanks. Yeah. So here we only have actually, you know, after printing this particular column, I only have one column left, right? If I print out this fifth column, this input file, which contains multiple columns, now the output from this command up here will give me only one column. So we use the sort command to sort according to the first column because I have only one, then I print the output. So this is basically the sorted fifth column of the original data input, but I only print out the fifth one. Okay, so now we're going to do something a little complicated. So as I mentioned previously, org is an enclosed environment symbolized with a single code. So whatever outside is a separate environment. The $sign, the variables is not visible inside org. But sometimes you may want to pass some variables or parameters into the org for the process. So there's a mechanism allows to do that. It's using the keyword -v. So this is basically command here. You see -v, where I pass the value $i here. This $i is a $i in the bash environment. And this $i gave the value I. Okay, and this I is a parameter inside the org. Now, if you see here in this environment, this $i is basically the reincarnation of this original I in the bash environment. So I use the same symbol here. It may look a little confusing, but it's just for convenience to write the command, but just keep in mind what's happening here. So in this $sign, its interpretation is the original bash value, which I took from this loop. Then I pass this input, which is the iterator from this loop, into the org environment by using this parameter -v. Then I print out this particular column, which is determined by the input value of this loop. Of course, I only print out the 3 lines. As you see here, the printout is changing because as the loop goes through, the columns number is changing from the first until the fourth. Is this clear to everyone? Any question here? Okay. So yes, so this is basically parsing a parameter. In org, you can also process some mathematical operations. In this example, what I'm showing here is basically I want to print the logarithm of the fifth column because the fifth column is a number, positive number. I can take a logarithm. Now, log is basically an arithmetic operation already predefined in org. This one, n(r) greater than 1, is a pattern, as we talked before. That means I only perform the option for the rows that's greater than 1. Okay. I can also perform some string options. Substring, people probably may be familiar if you code in Python or R. Substring is a take part of the string that's a take part of the original string. So in this case, I subtract the string, which is the output of the column 1, and subtract the first until the fourth position of this string. So you end up with this four character string. I also can provide if conditions. If condition is very similar to the C syntax. Use the greater sign to represent the third column value greater than 2. Then I print the output as shown here. Or I can make the if condition a little more complicated, I have two options, right? So in this case, I ask the pattern to recognize if this row is the first one, the header, then I print two values, two strings. One is the index, the other one is $0. $0 represents the entire row of my input file. So that's why you show here in the first row, I print out index with a small space here. That's a small space. Then entire first row. Then if NR greater than 1, that means if the scanner start moving to the next row, I will print the NR minus 1 and $0. NR minus 1 is the row number minus 1 because this is the first row. I want to call it index. Then later on, I will just move the count of rows by one number in the descending order. So the second row becomes first, and the third one becomes second. So that's how the output is shown in here. You can also use the awk, a very easy, handy function, to do some numerical calculations. For example, this example to calculate the maximum value for this particular input file, and which is the maximum value for the fourth column. Is this obvious to everyone? Do I need to explain what it's doing here? If you're coding in Python or R, you probably recognize this action here. Any volunteers want to talk about this command?
Well, yeah, try to split the full command line in step and try to comment in what it's doing. Okay, who wants to go?
So I tell you, this action is basically print the maximum value for column 4. Yeah, the only trick is pretty much here. Anybody can give a try to understand what's going here? How is getting the maximum value?
Anyone? Farzad, I know that you know. Okay, first part, what is doing? If number of row bigger than 1. Let's go step by step, no?
Okay.
Then
what is this?
Part. Yeah, what is that?
So it's a condition that only executes if the number of rows is higher than 1. So only when that is true, the next part of the line is executed.
Okay,
very good.
Giuseppe, do you get it? My voice came to my side is a little low. If you get it, maybe you can.
Yes, so always have to keep in mind that Oak is processing the text row by row. Okay, so it's not ingesting everything, and so he read one row and then he store what he need to store and then goes to the next row and so on and so on. So keep in mind, that's why the dollar, in this case $4, is identified with the sign dollar, because it's the value for the first row, column 4, and then the value of the second row, column 4, and then the value. So it's changing cascade mode. Okay, so over there, what is doing in the first, actually in the second row, because we say bigger than 1, we store it that $4 is bigger than max. In that case, in the first line, it just define the max as the value for $4, and then the second part is max is equal to $4, and then goes to the next line. So if the condition $4 is bigger than max, then he's put back again the max equal to $4, keep going. So if I find something smaller, that condition is not applied. So this is the pattern that does during the reading. Okay, during the reading. Then when you finish, you have the end that just print max. Okay, so if you remember this cascade mode in your thinking, you can process in the same way like Oak is doing. Okay, a bit more clear. Alex, what do you think?
Yeah, it's interesting syntax.
Yeah. So try always to keep in mind what is, I always do it. Okay, the first row is doing this, then is storing this variable as max, and then the second one is, so before Longzhu and I, okay, sometimes we still do it like 20 lines of Oak, but now this is what you need, just one line, print number $1, $2, some if condition, and that's it. Okay, because then you can get smaller your data set, and then you can import inside R, inside Python for table manipulation and statistical analysis and so on. But these are really fundamental. That's why we teach for shrinking the data. And I will show to you guys after the Longzhu talk how you can deal it with big data into the cluster. Yeah. Okay.
Okay. Thanks, Giuseppe. Yeah, probably pretty much explained. It's basically going through to find the max value by replacing the smaller ones. Now we move to the next one, and the syntax pretty much similar to before. I already explained the syntax very much, in pre-examples. So can somebody tell me what I'm doing here? What this action is doing? This is if condition, right? What is it? It's doing some, keep in mind, the way to think about awk is basically a scanner. So when you have an input file, it starts scanning row by row. And this $3, the value is changing. It's not constant. So the first time when the scanner is at the first row, this $3 represents the first column of the first row. I'm sorry, the third column of the first row. When the scanner moves to second row, this value change into the third column of second row. So it's keep changing, right? Now it's doing here.
So I think in that line, if the is the value of the column 3 is equal to 7, then it updates the value of sum by the previous sum that was before plus the value of the column 5.
Yes, that's exactly doing, yes. So it's actually,
I have a question about the previous command that Alejandro raised on the chat. He asks what is the value of max on the first iteration of that loop. And on the first iteration, well, there is no max yet. So I believe the variable has not been created. So does one need to declare the variable before starting the loop, or is okay to leave it that way? In the line 37, the max is only created on the second iteration.
Yes, great question. Yeah. So normally we declare max in the beginning. You can use the begin function to declare max. But if you don't declare, awk generally initiates this value as 0 in the beginning. It's most time. But it's a good practice if you put, you have the begin action here where I have to begin, yeah, here. If you say sum includes 0, that's be fine. So it's much clearer. But if you don't, normally start from 0. It may have some unexpected result, but normally it's okay.
Super, thanks.
Yeah. So where are we now? So yeah, so this is basically, checking if the third column has this particular value. If it does, then it sum up the corresponding value in the fifth column and point out a final summation. Similarly, I can check 2 columns. If the third column is 7, the second column is 205, then I sum up the value of a fifth column. So a few actions come out very handy. Let's say if you have a table where you have different conditions, right? You want to subset this table based on the value of certain columns. This comes down very handy for you to restruct the table to your desire. Of course, you can do some conditions in R or Python, but awk is very easy for you to do a fast action. If you want to just do some checking on terminal, it's very useful, and I use it quite a lot. Okay, so this is about the subsetting and column options. We can also do some queries to manage, do some file management. Let's say if I to list this files under the time folder, and I assign the 5th column value to S, and if S is greater than 1 megabytes, I print this result. Apparently, I don't have any, but this is a very handy use for awk, where you have the pipe. Instead of providing an input file to awk, awk can also take the output from the list command of bash. And the last one is also quite interesting. In this case, the output file name X was determined inside action. So see here, the X is actually the output of print, right? No matter what I print, I redirect the print output into X. And X is a string, block file +i. And that's become the file name. This string +i is a file name that was given in the action of X. Then what is being printed? Printed is based on this pattern, right? If the pattern is satisfied, then the print action will take place, and the print will go into the output, which is the X defined in this particular action box. And here, basically, it will retrieve the files every 1,000 rows to make a new file. You can run this command, you can see the output. I think awk comes down a very easy and handy tools for you to manipulate data files. It's very fast. It doesn't occupy a huge amount of memory, and it comes been very handy in many applications in Linux programming environment. I think that concludes the part of my talk. Should you have any questions, feel free to post in the chat box, or just give a shot here. If you don't, I will just turn over back to Giuseppe. Yeah, seems to be very clear, Giuseppe. No questions. I'm very proud of myself.
Yes, thank you, Longzhu. Yes, in the as I mentioned before, in the past we were using quite a lot awk for heavy text manipulation and so on. And actually, over here there are some other example in the material how to dealing with query a data set on the base of header name, or some other subset a limited number of column headers and query the data set on base on header subsection. I mean, we don't really do it anymore, this stuff, because we have Python and R. But feel free to try and having a bit of these trials by your side. Okay, so but usually these are the most important lines that you need to remember. So print columns, especially these one are very handy, especially for the print number of field to see if the column has the same number. So in this case, for example, everything was 5 columns, so it's not a problem. But if you have one line that has less row, so you can identify quite fast. So this is so with this one are more than enough to do some open manipulation before to import in Python in R. You can create also CSV. Actually, in particular, over here, the printf, you can do it a lot of flag. For example, if you put percentage 2.f, means that you can store it only 2 digits after the dot. So you have a lot of, with the printf, you have a lot of manipulation that you can do it. You can create CSV file. You can, so in this particular case, you have the -n. Actually, let me enter and I can show you maybe it's much better. So let me copy this line. So taking out this, yes, perfect. So the printf, for example, you can, with the printf, you can you see my terminal? Yes, no? I'm sharing. Yes, no, yes, it's sharing. So the printf allow to, for example, if you put over here n, a comma, so it's going to put a comma after, okay? So if you have another number here, printf, for example, 3 is going to be the comma separator. So you can add the information over here. Or also, for example, this one is a syntax that I never remember if it's 2, sorry, .2.3 is correct. Yes, so for example, is printing only 3 digits, and the \n is giving to me going to the next line. Okay, so these allow you to use the printf in a fancy way for this kind of operation and text file. So this is the stuff that you need to remember. So try to get familiar with awk, piping it together with bash, and you will be performing quite interesting way of processing. And in particular, I want to show you this handy situation where you have a large data set. So for example, in this folder, I have plenty of file, we will see, and in total there is 4 gigabytes of file. So it starts to become quite heavy, even for the ls is not listing, because there are, actually now is listing, there are 30,000 files. In this case, even the find command is much faster in listing this file. These are text files, for example, that storing information about discharge data set. So you have the station with a lot long information, and then you have the time series for each month. Okay, for each month you have a particular discharge in the river. So in this case, mean. So this is a typical example where manipulation with bash will be extremely important and grateful before importing it in Python in R. And let's see how we can proceed. So for example, if we want everything, let's say let's pick up another date that we have more times. So if we want everything in the 90, so I can do just grep, and of course I can put all the name. Let's put only CA state for California. This way is coming up the result quite fast. So this one is giving to me all the station, for example, over in California for this period of time in the, okay. So now I'm interested only in the second line. I can do, okay, what I can do on the second line, can somebody help me? So oak, I'm interested only in the second line. So parentheses, and then print $4, sorry, $2. Okay, so now is listing, for example, all the different for that date, only column number 6. So what I do it over here, I can see that there is some file that is NA. Okay, I don't want this NA. So how we can do it? Can you help me? There are 2 ways. Anyone? What I can do here? If, come on, anyone? Marianne. If $2
is equals to NA or not?
Okay, not equal, bravo, $2 not equal, and the not is identified by this, perfect, not equal to NA. Perfect. Print. Oops. NA. Yes, print $2. So now we can scrolling down. Okay, there is also $2. Okay, so here there is a little error. I mean, more than an error, we need to identify what is happening. So this is one case is that Oak, this is the comma separated file. Okay, so Oak is not able to treat as a starting, as a default, comma separated file. So we need to inform Oak that our column separator is the comma. So we go back and we do dash f comma. I think I need the quotation. I made the parentheses. Okay. So now I can see that is printing. Is taking out is recognized that I don't want NA and is removing also NA. So but I need to identify that my separator is the comma. So this is how you treat in this way. So so actually even better, you can put also another if condition now. Okay, so inside here, because over here, you have already a reading of the file, and then you do a second operation. So you can even concentrate everything. But this is fine as an example. So for example, I want the sum, still some NA over there. So if $2, Longzhu, why there is still an A here? Any idea?
I think maybe there is an A also in another column. Maybe you should choose all the columns.
$2 is there. $2. No, it should not. $2. Anyway, you need to find not equal. So if we say equal to an A, just printing on an A. Not really. So if something happened with need to investigate a bit more. Anyway, column number 2 should be this one. Maybe it's also due to that we have also this space over here, so it's making some strange stuff. So we need to also identify that there is some there is something going on over there. Anyway, let's suppose that we take out the NA, that the NA is not working, or let's see, I don't know why that NA, so we can do it in another way, that even if it's not super efficient, because it's reading the file 2 times, but we can, I'm sure that like this, grabs -v, NA, so over here is not, now I'm sure that they are out, okay? So now, for example, I want to do the same operation that Longzhu did it, like sum all the column, and you say sum equal to sum plus $1. So now you don't need anymore to identify the separation because the comma is gone. Okay, so and then you can say, okay, and print sum. Print sum. So this one now is quite long procedure because it has to go through all the file, and then it's going to give me the sum of all this column and this. So you can do it, this kind of operation, quite in a really fast way. Something really, so now is, of course, is doing, so you have this one as the sum of the file. Maybe it's a bit small, so we need to double check if it's correct, but maybe it's quite correct. So something that also actually I discovered like a few years ago after years of working with WK, I don't know if you know, that you can pass directly the wildcard of, so you can do something like this. So Longzhu, did you know about this? So you can, so it's going to use not only one input file, but all the output file. I never tried, I don't know why it didn't come to my mind, but
Yeah,
so
you can't concatenate all the files input.
yeah, but you don't need actually. You don't need to
No,
concatenate.
Awk will do it for you.
Yeah, Awk will do the concatenation for us. So we just identify the separator. So now we can do perfectly the same. Okay. So now, for example, is printing. No, now we need to print $2. So it's doing the same, but with all the file. Actually, I don't know why it was never coming to my mind to concatenate. And you can see that now, for example, the print function. This is a good example. Does not give you actually give you a scientific number, so you can use it, the printf, to have the full path of the. So if you do dollar, so you can use also, for example, integer. It's like this, no? Perfect. So you can do integer to get the full, and now you can see that you have the full, as you don't have the scientific number shortness. Okay, so this allow you to, and this, as I mentioned, there are 30,000 files. So even before to import in Python, for example, this file, they have all this information that you don't really need it, for example, or other way around. You want to create a CSV file with this information. This is a very, let's see another example, super handy. So there is another one that is very, very useful in this case. You can grab, for example, you can grab latitude, okay, and you get this one. So let's print whatever we need. So 1 column, 2, 3, and 4. So print AWK print $4. So by this one, you can get the latitude. Okay. So now, for example, you do perfectly the same. Yes. So you do perfectly the same, and you nested each other with a. Now you will see what I'm doing. Okay, so I'm grabbing the two functions, and now I nested one beside to the other one. Okay, so over here, go, and I use paste. This is another value to have the two output all together. So in other words, this is what I'm doing. Over here, this is one. I put this symbol, this way you can get familiar. Okay, so this is one. Then you have the second information that is perfectly the same. Okay, but rather than grabbing the latitude, is grabbing the longitude. Okay, so and then you have this one for this one for the second one, and now you have one command, and now you have one file that is going to be your x and y coordinates .txt. Okay, so this is very handy to immediately pull out your point location. Okay, so now you will have the file that is going to be your x and y over there, and of course you can plot it. You can do a CSV. You can import it inside PK tools for making a shapefile and so on. So this is how you nest it, and this one is this paste command again is doing, rather the append is doing one below the other. The paste command, it does like this. So you have 5 rows, so it's just matching all the. So it's very common. Be careful that this one is not dollar, but is redirect to the paste. So it's from here to here is one command, and then you have the second one over here. So I will put this line into the chat just in case you want to copy, paste. Okay, so this is just to give you a bit of feeling in this fast manipulation in large file and why we are using. Rather, if you have in R, you have to import it one file by one file, getting that. As you can see now, I'm just getting two numbers from this big file. So do I really need importing Python? Because Python is going to read all the file, you know. Rather this one is going to be extremely fast and very efficient. Okay. So again, try to use it as much as possible, all this command and with your data, and come up next Thursday. I hope that will be fine. And with some example that you want to share it, some doubt. So it's very important to have this kind of interaction among us. Longzhu, you want to